We're going to do some more examples, and these questions look really similar except for one problem. We've got some constants in here. So yeah, we got logarithm, constant. I've got a constant of 4 here. And we can't just say, hey, I'm just going to take the log of 1. No, you have to take log of everything. So we have to think of ways to turn this constants into logs to make it so we can solve them the same way we're solving the last ones. So I have to think, okay, 1 equals log, well, what's our base here? Our base is 10, so log base 10. So we're looking for what this argument would be. So 10 to the power of 1 is equal to, well, 10. Meaning if I can replace 1 with log 10 to the power of 10, and that's perfectly acceptable. So I have log 8x plus 4 equals log 10, I don't need to write the 10 there as a base, plus log x plus 1. Now that I've done that, I just need to make it so both left side and right side are just written as a single logarithm. So our left side is already 1 log, so we got log 8x plus 4 equals, here we've got an addition, so we can use the product rule, so it's going to be 10 log 10 times x plus 1. And now that both the left side and the right side have the same logarithm with the same base, we can cancel out those logs, and we're left with 8x plus 4 equals, I'll do the distributive property right away, so you get 10x plus 10. And I'll subtract 8x from both sides, so I get 2x, and then I will subtract 10 from both sides, so you get negative 6. Divide both sides by 2, so you get x is equal to negative 3. Now our next question has a similar problem. We've got a 4 here. So we've got a logarithm base 2, so we need to make this a base 2 on this side. So we have to think log 2 base 2 of something equals 4. A couple ways we can think of this. We can think, hey, 2 to the power of 4. Well, that's actually 16. So that means log base 2 of 16 is equal to 4. That's one way we can think of this. Or, and I'm not too concerned about which way you think about this, we can just put, you see this is their base, this is our exponent that actually happens inside here. And when this base matches the base of the power inside the log, the exponent is our answer. So really this base is always going to be that base for our power, and then our exponent is going to be whatever we're looking for, if that makes a little bit of sense. Either thinking works, it doesn't matter. You're going to get the same answer. So here we're going to end up with log base 2. I will not do anything with this squared yet. I'm going to leave it until we can get rid of the logarithms. So this is log base 2 of 16. So now that it's log 2 on both sides, and we've got logarithms equal to each other, I can get rid of them. So we're left with x plus 3 squared equals 16. A couple different ways we can do this. I can either expand this, and then I'm going to have to factor it, or I could just square root both sides. So I'm going to choose to square root both sides, but we are going to get two separate things happening here because it's going to be plus or minus 4. So x plus 3 equals positive 4, and then x plus 3 equals negative 4. So therefore I get x equals 1 and x equals negative 7. So therefore we get two answers. All right, our last example here, we have 2 to the power of x equals 2500. So this time we have no logs to start with, and I'm going to turn this into, we could turn this into a logarithm. Or I could just take the log of both sides. Now I'm fairly certain that 2 to the power of x is not going to be a nice whole number. Like I'm not going to just know the answer. So I'll just take the log of both sides then. So we get log and 2x equals log 2500. This, I can use my power law, so it's going to become x log 2. And sorry, that looks like a base right now. So log 2 equals log 2500. I'm going to divide both sides by log 2. So we get log 2500 divided by log 2. You can put that in your calculator. That's why we chose to use log with a base of 10. And you get 11.3.